Hi students, today we will start with a new module. Right? So as per your syllabus, this is module 4 in that first chapter, DC motors. Right? So in this we are going to study regarding, in this chapter, principle of operation, how the motor is going to operate. Right? So what is the role of back EMF, torque equation, types of DC motors, characteristics of DC motors. For your syllabus you have only the characteristics of series and shunt DC motor, and last is applications, right? So before going to start with this chapter, first we will clearly define what do you mean by motor and what do you mean by generator, right? So motor is nothing but it is a device which converts an electrical energy into mechanical energy, right? So here the input is electrical energy, right? So using that electrical energy we are going to convert that to mechanical energy, right? So in your day to day life ನೀವು ಮನೆಯೊಳಗೆ ನೋಡಿರ್ತೀರಿ ಏನಂತಂದು ನೀರು ಏರ್ಸಾಕ್ ಮೋಟರ್ ಹಚ್ಚಂತಂದು, right? So ಮೋಟ್ರಿಗೆ ಇನ್ಪುಟ್ ಏನು ಕೊಡ್ತೀವಿ ನಾವು, we are going to give electricity as a input, right? And that motor is going to do the mechanical work. That mechanical work is nothing but what? Lifting the water ಅಥವಾ pulling the water from tap to wherever you want, right? So motor is nothing but what? It is a device which converts electrical energy into mechanical energy. If the process is vice versa, ಅಂದ್ರೆ ಉಲ್ಟಾ ಆತಂದ್ರೆ, if the device is going to convert mechanical energy into electrical energy, then those devices are called as generators, right? So current ಹೋದಾಗ generator ಹಚ್ಚ ಅಂತ ಹೇಳ್ತಾರೆ, right? So ಏನಾಗುತ್ತೆ, they are the input we are going to give it as a fuel, right? So it may be petrol or diesel, the input is a fuel, right? So that fuel will be converted into electrical energy, right? So you are going to study DC generator in the second chapter, right? So don't worry about that, but you should be clear about motor and generator, right? So ಈಗ ಒಂದು ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್ ನೆನಪಿಟ್ಕೊಂಡು ಬಿಡ್ರಿ. ಮೋಟರ್ ಅಂದ್ರೇನು, ಮನೆಯೊಳಗೆ ನೀರು ಹಚ್ಚಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಲ್ಲ, ಇನ್ಪುಟ್ ಏನು ಕೊಡ್ತೀವಿ, ಎಲೆಕ್ಟ್ರಿಸಿಟಿ, ಔಟ್ಪುಟ್ ಏನು ಬರುತ್ತೆ ಅದು ನೀರು ಜಗ್ತೈತಿ, ಇಟ್ ಈಸ್ ಅ ಮೆಕ್ಯಾನಿಕಲ್ ವರ್ಕ್, ರೈಟ್? ಸೊ ಜನರೇಟರ್ ಅಂದರೆ ಏನಾಗುತ್ತೆ, ಇನ್ಪುಟ್ ಏನು ಕೊಡ್ತೀವಿ, ಇಟ್ ಈಸ್ ಅ ಫ್ಯೂಯಲ್, ಇಟ್ ಈಸ್ ಅ ಮೆಕ್ಯಾನಿಕಲ್ ವರ್ಕ್, ರೈಟ್? ಸೊ ಔಟ್ಪುಟ್ ಏನು ಬರುತ್ತೆ ಜನರೇಟರ್ಲಿದ್ದ, we are going to glow the bulbs, we are going to use the computers, that is we are going to use the electricity. Output is electricity. Electrical to mechanical motor, mechanical to electrical generators. With these basics we will go for the first topic of this chapter, that is working principle. On what basis the DC motors are going to work, right? So already you people have studied in your lower classes, that is always the motors are working on the basis of Fleming's left hand rule principle, right? So that we will discuss now, right? So a DC motor works on the principle that whenever a current carrying conductor is placed in a magnetic field, it experiences a force, right? So ಏನಾಗತ್ತೆ ರೀ, ಎಲ್ಲರ ಕರೆಂಟ್ ಕ್ಯಾರಿಂಗ್ ಕಂಡಕ್ಟರ್ ಇತ್ತಂದ್ರೆ ಅಲ್ಲೇನರ ನಾವು ಅಥವಾ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಪ್ಲೇಸ್ ಏನಿದು, ವೆನೆವರ್ ಅ ಕರೆಂಟ್ ಕ್ಯಾರಿಂಗ್ ಕಂಡಕ್ಟರ್ ಇಸ್ ಪ್ಲೇಸ್ಡ್ ಇನ್ ಅ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್, ರೈಟ್? ಸೊ ಅಂದ್ರೆ ಕಂಡಕ್ಟರ್ನ ನಾವು ವಿ ನೀಡ್ ಟು ಪ್ಲೇಸ್ ದಟ್ ಇನ್ ಅ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್, ರೈಟ್? ಸೊ ಇಟ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸಸ್ ಅ ಫೋರ್ಸ್, right? So that force is given by what? That is magnitude of the force is given by F is equals to BIL, right? So where F is what? The force experienced by that conductor. Now yakandre we are going to place a current carrying conductor in a magnetic field, right? So according to working principle it need to experience some force. ಅದು ಏನಾಗಬೇಕು, ಒಂದು ಸ್ವಲ್ಪ ಫೋರ್ಸನ್ನ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡಬೇಕು, ದಟ್ ಈಸ್ ಯುವರ್ ಎಫ್, force experienced, and always the force is measured in terms of newtons. Next, B is what? flux density of the magnetic field, because we are going to place a conductor in a magnetic field. Yes, magnetic field aiti, that is given by the letter B, magnetic field intensity or flux density, right? So which is measured in terms of Weber per meter square, that we have already discussed, right? So magnetic field intensity or flux density is nothing but what? Flux per unit area, right? So flux is measured in terms of Webers, area is measured in terms of meter square, hence the unit is Weber per meter square. Next is what? Current flowing through the conductor, because we are going to place a current carrying conductor, right? Current flowing through the conductor, and that current is measured in terms of amperes. Last is what? How much length of conductor we are going to use, that is L, length of the conductor in meters, right? So F is equals to BIL. Adendra, if it is perpendicular to the surface, perpendicular it will be BIL sin theta, right? So don't worry about that, you remember only F is equals to BIL, where F is force experienced in newtons, B is flux density of the magnetic field, that is measured in terms of Weber per meter square, and I is what? Current flowing through the conductor, L is length of the conductor. ಅಂದ್ರೆ ಈಗ ಒಂದು ವೈರ್ನಾಗ ಏನು ಕರೆಂಟ್ ಹೋಗಿರ್ತಲ್ಲ ಆ ವೈರ್ ತೊಗೊಂಬಂದು we need to place that in a magnetic field with flux density of Weber per meter square. Because of that, that conductor is going to experience that some force. It may be inward force, it may be outward force, it may be upward force, or it may be downward force, right? So but it experiences some force, and that magnitude is given by F is equals to BIL. And what about the direction of the force? That is given by Fleming's left hand rule, right? So now we will discuss regarding Fleming's left hand rule, right?